we go. All right, so looking at your notes, the first part of the assignment that we are doing today is we're going to look at graphs of piecewise functions, and we're going to write the pieces out, so we're writing up the function. And what I did to make this a little bit more simple for you guys is the only functions that I used were linear, quadratic, and absolute value. I didn't use anything else, okay? And it says to write a possible piecewise function because it is possible, like for number 2, that's an absolute value graph. But if you wanted to be tricky about it, you could call it 2 different linear graphs, right? So somebody could write it as an absolute value. Somebody else could write it as one linear that connects to another linear. You could write this as a linear graph, or you could write it as an absolute value graph where like the V part got cut off, because we saw that happen sometimes when we were graphing them by hand. We would have like the V shape, and then when we erased part of it, we erased it so it looked like a straight line, even though it originally was a V. So you're going to write a possible equation that works for the function, but there are multiple answers in some of these cases that would all work, okay? So in the case of like a quiz or a test, you don't have to match mine perfectly to be right. I would be able to look at yours and be like, yeah, that would work too. Does that make sense? Okay. So if we look at this first one, I can see 3 different pieces. So I know that my piecewise equation is going to have 3 different pieces. And typically when we write our equations, we go from left to right. But if you go backwards, people are going to look at you funny, but they're not going to like say you're wrong. Okay. So I can see I've got a linear part. And for that, I'm going to remember y equals mx plus b. So that means I'm looking for a y-intercept and a slope. I have a horizontal line. Do you guys remember how to write horizontal lines?
Uh-huh.
How do we do it? Y equals a number, right? So y equals 3 in this one. Yep. And then the last one we have is a quadratic. Okay? So for the linear equation, can you guys see what the y-intercept is? It's got a y-intercept of 1, so we know it's got some sort of slope times x plus 1. And then can you guys tell what the slope of that is?
2.
So as we go to the right, it's going down 2, right 1, down 2, right 1, down 2, right 1. And so we're going to call that negative 2 over 1, or just call it negative 2. So negative 2x plus 1. And what are the x values that we see that for? Negative ones, right? So I can see here, this is where x is 0. Can we equal 0?
No.
No. So it's x is less than 0 because it's all the numbers less than 0. So we're going to say x is less than 0. Then we have our horizontal line. 3. And what are the x values? We have a sandwich, right? So we have x is in between something.
0 and 4.
0 and 4. Should I have any equal to's in there?
The first one.
The first one, equal to 0, because that's filled in, but not equal to 4, because that one's not filled in. And then the last one is a quadratic. And what I have to remember about the quadratic is that those usually start at 0, 0. If we looked back at our parent function packet, we would have a quadratic at 0, 0. So it's moved to the right. How do we include that in the equation? We do x minus 5, and then how do we make it look like a quadratic? Squared. Perfect. Okay, and then what do we notice about the x values? It's going to the right, so it's going to be a greater than. Greater than what? X is greater than 4. And then what else do we need with that? An equal to. X is. Mm-hmm.
Someone applied 2 or 3.
Oh, 2. So sorry. So the horizontal was at 2. I wrote down 3. That was my bad. Thanks, guys. Okay. So for number 2, we also see 3 pieces. So I see a horizontal line, an absolute value, and a straight line. You could do this as 4 pieces if you wanted. You could do 2 different lines. All right, so if you want to do 4 pieces, you're welcome to. So if we did 3 pieces, how would we write our first piece? -6. And what do we know about the x values? Less than -4. Can it equal -4? No. So -4 has an open circle and it goes to the left, which is why we're saying x is less than -4. All right. This absolute value graph is not in the middle like normal. It has moved to the left one. So how do we write that? Yep, absolute value sign, right? +1, very good. Okay, and this is one of those sandwich ones. And what is it sandwiched between? -4 and 2. Should I have an equal to for anything? Equal to -4.
Why is it absolute value?
Because it's a V-shaped graph. Okay, and then last one, we have a straight line. I can't see my y-intercept, so I'm going to go ahead and continue this straight line so that I can see it. So what's the y-intercept? 0. So I have some sort of slope times x plus 0. And what's the slope? Yeah, -1. It goes down 1 over 1, down 1 over 1, down 1 over 1. So it's a slope of -1. So I wrote -1x plus 0. If you don't like the fact that it's a plus 0 because you don't think 0 should be written, then you don't have to write it. You can just erase it. No big deal. You could also write -x instead of -1x. So the most simple form of this one would just be to say -x at the bottom. And then what do we know about when it's going to be -x? X is greater than or equal to 2. Good. Okay. How are we feeling about that? Good? Okay. Okay. So, for the word problems, you guys ready?
No.
You're not ready?
Can we just...
Whew. Okay, we're going to do this. We're going to be okay. We don't have to do a ton of them. You ladies ready? Okay. So, a local amusement park charges admission to groups according to the following policy. If you have a group of fewer than 50 people, you have to pay $35 per person. If you have a group of 50 or more, you have a reduced rate of $25 per person. Okay? So first, when we start these problems, we're going to decide what our x value is going to represent. So what should x be? What's changing in the problem?
The dollar sign.
Not the dollar. Well, the price is, but the number of people, right? The price, the number of people tells you which price to use. So we're going to say the number of people is what's changing. And after you figure out the number of people, then what does that tell you?
How much?
How much it's going to cost. So we're going to say x is the number of people. The function itself is going to tell us the total cost for all those people to go to the amusement park. Okay. So we had 2 different situations. So when I write my piecewise function, I'm going to have 2 different pieces. And the first piece was that groups of fewer than 50 are charged $35 per person. So if I have 1 person, I'm going to pay $35. If I have 2 people, I'm going to pay $70. If I have 3 people, I'm going to pay $105. So how do I write that? Times
35.
yes. So we're going to say 35x. And what number of people does that work for? Less than 50. So I'm going to say x is less than 50. Is that when we have 50 exactly? No. Okay. Can I have -3 people? No. So I shouldn't include all the numbers less than 50. Because I shouldn't include -3.
So you put
0. Yep. I'm going to say for x is between 0 and 50. For most story problems, you're going to have to use 0. You're going to have to start off with a sandwich. Well, you're not going to have less than 0 people,
Oh.
right? So we're just saying that we have at least more than 0 people, okay? Now, you can put equal to here if you want, because if you have 0 people exactly, then you have 35 times 0 people and you're not paying anything, and that makes sense. If you don't go, you don't pay. That's logical, okay? So you can put the equal to there. You cannot put the equal to there. It also makes sense to think I'm only going to use this policy if I'm actually going. So here, as far as using 0 or not using 0, it doesn't matter either way. It makes sense both ways, okay? All right, the other policy is $25 per person. So we're going to say 25x. And when do we use that policy? Yep. Greater than or equal to 50. Okay. So how much will it cost for a group of 25 to go to the park? We're going to say f of 25. And then which function are we going to plug it in?
The second one. No, the first one.
The first one. So we're going to say 35 times 25.
870.
Is it 870?
I don't know.
Oh, you were just making up numbers.
Yeah, somebody said that.
875. You were very close. All right. And then, I don't know, I've had not very many people in here in my class. A few. What do I say? People who have had my class before, what do I say about story problems?
You have to remember them.
You have to write a story answer, which means we answer these in a sentence, not just with a number. So I say, it will cost.
If they're not going to tell me to write it on the test, why would I do it?
So the reason that I'm having you guys do it is because you're in honors pre-calc. The classes after this are AP Stat and AP Calc, and both of those classes have you interpret things in context. And it's easier if you have interpreted them before and you're used to thinking about it. Just making sense. I know what this number means at the end. Okay? It will cost $875 for 25 people to go.
That's cheap.
Yeah, I feel like that's a lot of money, but I also don't really go to amusement parks with 25 people. All right, so next, how much will it cost for a group of 85 to go? We're going to say f of 85. And which piece are we using? So 25 times 85. If you need to get up and use, grab a calculator or trade something for a calculator, that's totally fine. Okay.
2185.
It will cost 2,125. I gotta fix that. Okay. $2,125. Did I sound urban?
Yeah.
$2,125 for 85 people to go. You guys are giggling like I don't sound cool. Thank you. Thank you.
No, it's them over there giggling. We not good.
All right. How much money will a group of 49 people save in admission if they get one more person to go? How do we figure out the answer to that question? We plug in 49.
In both of them.
So you can't plug in 49 to the second one, right? So plug in 49 and plug in 50 and see what the difference is, right? So find the cost for 49 people, then find the cost for 50 people and compare the prices. So 49 times 35 compared to 50 times 25.
I got you. Give me 1 second.
Mm-hmm.
It is 465.
We got how many first? 17 and 10?
Mm-hmm. Okay.
That's how we say numbers now.
And then when we subtract them, we get
465.
465. otherwise known as $465. All right. They will save $465 if they get another person. Yeah, that's a lot of money saved. All right. So this is one common type of piecewise function story problem where it has like clearly different scenarios, and then and they're pretty easy to set up. It's just if this scenario then this, if this scenario then this. Then we flip over the page and we see that there are some that are a little bit less clear. And so these are the ones that I want to really help you with, because they're once you understand how they work, you can apply it to a lot of different situations, but you have to be really careful the first time you do them. So we have taxes for $20,000. The first $20,000 of somebody's income is taxed at a rate of 15%. And then any money over $20,000 is taxed at 20%. So here we don't have two clear situations. We have one situation that applies to everything less than $20,000, and then for the other one, it's like you kind of use the first situation, but you kind of use the second situation. Do you guys see that? It's not as clear cut as the other one. The other one was, if you have less than 50, use this. If you have more than 50, use this. This one says start with the 15%, and then if you have extra, use 20% for the extra. Okay, that's a slightly different problem. So here we're going to say X is represented as, they tell you in the problem, what do they say? Dollars, X dollars. So that's the income, right? That's how much money you have. And then this time they said T, so we're not allowed to use f of x because they told us to use T. So T of x represents what? Tells you in the problem, the total tax. All right, so T of x, and again we have two situations, but one is a little bit dependent on the other. So the first thing we're going to say is 15%, right? How do we write 15% as a number? 0.15, right? We don't use 15, we use 0.15 or 0.15. So I'm going to say 0.15 times however much money you made, right? Okay, so we're going to say X. Okay, 0.15 times X if your income is what? Lower than 20,000. So X is, can it equal 20,000? It says the first 20,000. That means you can equal it. They didn't say less than 20,000. They said the first 20,000. Okay, so less than 20,000 or equal to 20,000. Can I have negative $500 for my income? No. So I'm going to say that this is a sandwich. I'm going to put 0 on the other side. Okay. The other situation is I could make more than $20,000. And then for the first $20,000, I have to pay the 15%. And then for the amount of money that's more than $20,000, I have to pay 20%. Okay? So the way that you write this is you say 15% of $20,000 plus 20%, and now we have to figure out how you write down the amount of money that's more than $20,000. Okay? So if you made $65,000, how much were you actually going to pay the 20% tax on? $45,000. Okay? If you made $22,000, how much were you going to pay the extra tax on? $2,000. If you made $100,000, how much do you pay the extra tax on? Okay, how did you do the math for all of those? X minus 20,000. Okay? So X is the amount of money that you're getting paid. you're going to subtract off the $20,000 that you paid the 15% on. Whatever amount you have more than that $20,000, you're going to pay the 20% for. Okay, do you guys see how I thought through that? This is a very common method of saying that two different things happened. So I do like whatever happened to that maximum of the first one, right? Like if you had $20,000, you've maxed it out, you paid the 15% for all of it. Plus, and then you have this little extra part over here. That's very common, okay? So this is like the second scenario. I think it's a little bit more difficult, but they're all pretty much the same, the way that they work out, okay? So for this one, we're going to say if x is, and what values can we use? Which ones would make it for it to be the second scenario? Bigger than 20,000. Okay. All right, so we're going to do two different scenarios here. We're going to check to see someone who makes $13,000 in taxes, what they would pay in taxes, and then somebody who makes $65,000. But you have to write that in because I didn't type it. Okay, so we're going to say T of 13,000 and T of 20,000. Now, some students don't like to leave the 0.15 times 20,000. They like to simplify that. So if you want to plug that in your calculator and get an actual number for that, you can. Okay, if it feels weird to leave it like that, that's fine. I kind of like the idea of leaving it because then you can see exactly where all the numbers came from and see how they make sense. Yeah?
So from the second one, where it says T of 20,000, what is it?
Oh, I meant 65. You guys, you have to actually say. Melon, thank you for actually saying and not just being about to say. All right, so 0.15 times 13,000 is going to tell us how much we're taxed for the 13,000. So we're ready to type that one in. The next one we have to type in a bit more. We have to say 15% of the first 20,000 plus 20% of the 65,000 minus 20,000. So that's 20% of 45,000, which is how much extra we have. So we got two things to type in. Anyone have the first one?
Yeah.
What'd you get?
1950.
Okay. Anyone have the second one? Double check and see if you have a typo somewhere. You might have a typo. Should be 12,000, yeah. All right, I didn't leave you guys space to write a sentence on this one, so you can go ahead and just put a $sign in front of those and call it good. So we have, when you type it in, 0.15 times 20,000 plus 20% of 65,000 minus 20,000. So if you have something other than that, it just means you probably missed a zero somewhere or had an extra zero somewhere. Yeah. Yeah, it'd be really easy to miscount your zeros there. Okay. All right, here we go. First one. Here we go. An SUV was purchased for $35,750. The value of the vehicle, are we listening? Decreases by $2,400 a year for the first 4 years, and then $1,700 per year for the next 6 years. Okay? So what does X represent?
Years.
The number of years. And after we plug in the number of years, what is the output going to tell us? The value of the SUV. How many situations do they give us? 2. They give us 2, right? One for the first 4
4
years.
minus 2.
One for the first 4 years, and then the other situation is for the next 6 years, right? If we talk about the first 4 years and the next 6 years, how many years are we talking total? 10, right? First 10 years. Okay. So we're going to go ahead and write this.
Decades.
You get so sassy when you get tired. All right. So we're trying to figure out how much the SUV is worth. We start off with $35,000 and some more. All right. So we do $35,000, and for the first year we minus $2,400. For the second year, that means we would have minus $2,400 again. So we've minused it twice. For the third year, we would minus $2,400 again. So we've minus $2,400 3 times.
You speak in another language.
So 35,000. 35,000 minus, and what are we subtracting off? We're subtracting off 2,400 for each year. So 2,400 times x. And what x values have this specific circumstance? The first 4 years. So how do we write them? 0 to 4. Does it include 4?
No. Yes.
Yes. First 4 years includes 4. Okay. Make sense? Okay. So what we're going to do now is we're going to figure out how much the car is worth after those first 4 years, and then we can do the next set of 6 years, okay? So I'm going to say the car right now is $35,750 minus 2,400 times 4. That's how I figure out what it's worth after the first 4 years, okay? 26,150. Okay? So this number right here, if you want to use the simplified number instead of showing where it came from, this is the math where it came from, but if you want to show the simplified, it's 26,150 if you want to write that instead. Okay? So after 4 years have passed, your car is now worth $26,150. And what do you subtract off now each year? So we're going to say 1,700. Now, it's not going to be times x, because if it's times x, then we're going back to those first 4 years and we're subtracting off 1,700 for those first 4 years. So it's going to be x minus 4. Okay? Because 4 is those first 4 years, right? 2,400 for the first 4 years. So if it's been 5 years, then we would subtract the 2,400 4 times and then subtract the 1,700 for 5 minus 4, which is 1 time. Okay? Yeah?
Why are we taking x and minus it from 4 instead of adding it?
Because if I do x minus 4, then I'm saying how many numbers above 4, how many years more than 4 has it been? So if it's 5 years, 5 minus 4 is 1 year above 4. If it's been 7 years, 7 minus 4 is 3 years more than 4. So it's exactly the same that we were talking about last time when we said, how far above $20,000 are you? We subtracted them. And it told us how far above we had with the extra. Okay? So the nice thing about this is it's minus every time. It always will look like this. Okay? So we said the first 4 years we have the one rate. And then the next 6 years, we have the other rate. Okay? So the other rate starts at year 4 and goes to what year? Year 10. So we're going to say x is between 4 and 10. So remember what we talked about. The first, leave the for now. You can get it in a second. For the first 4 years, we have one rate. For the next 6 years, we have another rate. And you guys said that makes 10 years total, right? 4 years, then 6 years makes 10 years total. So for year 0 through 4, it's one rate. And then after year 4 through year 10 is another rate. Okay? So we're going to say equal to 10 right here. And what we're going to do now is we're going to write how much the SUV is worth after it's been owned for 10 years. And I'm going to write out the math so that you can see what this means. Are you ready for your cheat sheet? Okay, you can come grab it. Your backpack's right here. All right. So we would say after 10 years, the price of the SUV is $35,750 minus the $2,400 for the first 4 years. And then minus $1,700 for 10 minus 4 years. And what's 10 minus 4? 6. So that means if it's been 10 years since you bought the SUV, for 4 years it decreased by $2,400 a year. And then for 6 years, it decreased by $1,700 a year. So the first 4 years were at the first rate. The last 6 years were at the last rate. Okay? So that's why we write x minus 4, because we just want to have the years that are above 4 counting for the extra rate. Okay? So let's go ahead and type that in and see what we get. Fill out a pass form. Nadia, what'd you say?
I'm done for the day.
I thought you said the answer.
I did.
So 15,950 is how much the car would be worth in 10 years. Thank you. All right, the second one you should be able to do because that's just like an example we've done already. So go ahead and take that one and see what you can do with it. All right, so you have a summer job that pays double time for overtime. So any hours that are above 40, you get twice as much as your normal hourly rate. Okay, your normal hourly wage is $10.25. You guys are so rude. I've been bullied. All right, what does X represent in the problem? Your number of hours.
Oh, what? She said shit.
And then f of x represents your pay, right? The money you get. Okay. So if you work a normal number of hours, you work less than 40 because your boss doesn't let you go over 40.
Which is crazy.
Which is pretty typical, right? They don't want to pay you as much. Then we're going to do 1025 times X. And that's how you figure out your pay, right? Mm-hmm. And what are the X values that you can use? Anything less than 40, so from 0 to 40. Can it equal 40?
It cannot. Yes, it can.
It can. It's only when it's over 40 that it's considered overtime, right? Okay. So what we do for the next one is we say first, if I have worked over 40 hours in a week, then that means I've gotten paid my normal rate for 40 hours.
So most of you working for nothing?
Nope. So I've got my normal rate for 40 hours, and then I'm going to add to that. Now when I make double, how much do I get? $20.50, but only for the hours that I work that are above 40. So what do I put in the parentheses? X minus 40. So if I worked 50 hours that week, then for 40 of the hours I got my regular rate, and 50 minus 40 is 10, and so for 10 hours I got my extra rate. And this is going to be for X's greater than 40.